Hello, this is a demonstration of discrete random variable question for the MEI S1 syllabus, and I'm going to use the June 2014 question 5 as an example. These questions all take a very similar form in that you've got first part is to work out a probability space or a value of k, and second part is just to find your expected value and your variance, which you can use our tables for. So first thing we always do is read the question. So starting at the top, the probability distribution of the random variable x is given by the formula. Here we go, p x equals r, and here's our formula. So for that value, for a value of r, the probability will be k plus 0.01 r squared for that particular value of r. So what are our valid values of r? They are 1, 2, 3, 4 and 5. And we'll put that in the table in a minute. Show that is question part Roman 1, k equals 0.09. And then using this value of k, display the probability distribution of x in a table. Okay, so I'm going to use the table approach from the start because it makes life a lot clearer for us all as we do our calculations as well. So I'd recommend you do it. So the first thing we're going to do is draw out the parts of our table, and in our top row we always put the values of r. So what are the valid values here? 1, 2, 3, 4 and 5. So looking at this, this is like having a 5-sided dice, isn't it? There are only 5 valid outcomes here. You're going to roll equivalent of rolling a dice and getting one of those 5 values. Okay, let's work out our probability for each one of those. So probability that x equals r. So in the first column we know that r equals 1, so our probability here is going to be k plus 0.01 times 1 squared. Yep. The second one is going to be k plus 0.02 times 2 squared. And we can follow our way on through. Sorry, 0.01, apologies back there, 0.01 times 3 squared, and then we k plus 0.01 times 4 squared, and finally k plus 0.01 times 5 squared. I've put a dot for times, yeah, rather than using multiplication. Okay. So what are these values? We can just simplify them and just put them in below. So k plus 0.01, then we got k plus 0.04, just working out this second term, k plus 0.09, and k plus 0.16, and finally k plus 0.25. Okay. So that's all in terms of k. What is it we need to solve this part of the problem? We have to remember one basic idea, that the total probability in any complete event equals 1. Yep. So here we had all our individual probabilities, and we know they must add up to 1. So if we sum all the figures above, let's go down a bit so we can see what we're doing. So if we sum all the figures, so our total probability from the table above is, we're just going to add all these up, k plus 0.01 plus k plus 0.04, etc. dot 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 dot. So we end up with 5 lots of k plus, adding up all these individual values, we get 0.55. And we know that must be equal to 1. So how can we reorganize that? Well, 5k must be equal to 0.45. Just taking that from both sides, so k must be equal to 0.09. We agreed on that? That gave us the first part of the answer to Roman 1. Second thing it asked us to do was put that into a table format. So let's just extend our table once more, and we'll work out the figures having replaced the general k with our actual value of k. So our first probability is 0.10. So I'm going to decided to put it into a new table on the bottom, so we've got immediate access to it. So the first value was 0.009 plus 0.01. That gave us our 0.10. Next one is our k plus 0.04, so that's 0.13. The next one is number 3 is k plus 0.09, which is 0.18. And the next one's plus 0.16, so that's going to give us 0.25. And finally, the fifth one is going to be our k plus 0.25, so that's going to give us 0.34. And we can check that if we add all those numbers up, the total is going to be 1, because that's what we're interested in. So I think we've completed part 1 of the question. Let's just go back and check it. Here we go. So it will show that k equals 0.09, that's correct, and we've displayed the probability distribution in a table. What's the next thing they've asked us to do then? They've asked us to find ex, and they've asked us to find variable x. So we've got 2 ways of doing this, long way and the short way, and if we're using the calculator, it'll be fairly straightforward. If we're doing it manually, it'll take a little longer, but I'll just show very quickly the manual approach first to finding ex. And one thing we do need to do is to first have a look at what we've got in our formula book. So let's pick that up. So here's what our MEI formula book says about discrete distributions, and it says they're random variables inside it. So it's given us our definitions. So first thing they asked us to find was E of x. And they've given us a formula for E of x here. So there's our formula. E of x is the sum of the x values times the p values. Well, here we've got our value, and we're using the term r for all of each of our x values because they're our actuals. So what we've got here is it's asking us to sum all our r times our p r. Yep, so we effectively this is just like finding a weighted average, isn't it? So what does that mean? It means multiplying the numbers together. So we multiply 1 by 0.1 for its probability. So we've got a 0.1 probability of it coming out with a 1 on. So we'd sum those two, we multiply them together, we multiply the 2, we've got a 0.13 chance of getting a 2, we've got a 0.18 chance of getting a 3, we've got a 0.25 chance of getting a 4, and we've got a 0.34 chance of getting a 5. So we could just go ahead, do those multiplications and add them up. That would be one way of doing it. So we'd have 1 times 0.1 plus 2 times 0.13 plus 3 times 0.18 plus 4 times 0.25 plus 5 times 0.34, which would give us an average of 3.6. Okay, we can use our calculator to do that, so let's use it. So we're going to menu, stats, then we're going to put our figures in. So what have we got here? First column will be our list, so our outcomes 1, 2, 3, 4 and 5, and here's our probabilities: 0.1, 0.13, 0.18. Sorry, I just put that one in wrong first, that one before. Put that in, 0.13, 0.18, 0.25, 0.25, 0.34. There we go. So we've now got our figures in there, and we can go in and we can get the calculator to go to calc. We've got a 1 variable. We just need to check that our calculator is set up correctly. So list 1 should be our values, and list 2 here, list 2 needs to be we need to take our second list because that's where our probability is. So that should now read frequency as list 2. So there we are. So now we go for a one variable calculation, and we've verified that we've got x bar, our x bar equal 3.6. And on the screen we can also see here that sigma x squared equals 14.74. We're going to use that in a minute to find our variance. So let's just write those that number down as well from our calculator, because we're done with the calculator now. Okay, here we go. Right, so let's just write those two numbers down. So x bar was 3.6, that's our mean, and our sigma x squared, which has actually got our probabilities attached to it because it's a frequency diagram, was 474.74. Okay, so let's have a look at our formulae here. What did they ask us to find? The second one they asked us to find was the variance, yeah? And there's a formula here for variance. There's the variance. We're going to use this version on the end. So the variance of x equals the sum of x squared p minus mu squared. Now the way they've written mu, that is actually our mean, so we can use x bar squared in its place. And you should be aware of a way that they are used interchangeably in these sorts of questions, even though one's actually a sample mean, x bar's for a sample mean, and mu is supposed to be the population mean. So let's get our variance x. Well, we know what the first part is there, that's the 14.74, and we've got to take away from it our mean 3.6, and that's squared. So the result is 1.78. There we go. So that's our variance of x. So with calculators that was pretty straightforward. How many marks did we get for that? We got 5 marks for doing that. If you did it manually, it could take an age, so don't do it manually, go the other way. So a very quick summary here. For a discrete random variable, remember that some of the probabilities must always add up to 1. You can either create you can find the k using that, and then you've got your formulae below, and you can use your calculator. And if you're using your calculator, make sure that the first one is set to your list 1, and the second one is the frequency in list 2. Always check that, or you'll get the wrong answers, and you can put the formulae into there. Hope that's of use. See you soon.